And I was thinking about how I can start, what kind of metaphor I can use this in order to kind of like a bridge to world of request response, world where you're writing your web apps, you're exposing your REST endpoints, in the world when everything happens with infinite stream of events. And last week or like week before, I happened to be in Frankfurt and my flight got delayed, and I was trying to figure out what's going on because there was no information, and the guy was at the gates. He was also trying to refresh his computer, try to get the information, so pull it information from somewhere, and all of a sudden I received notification that I actually knew faster than him what is happening when the flight will get back on track and things like that. So this is kind of like my personal experience of the things that I like to tell people in a real life, and how event-driven system, essentially event that came to my phone in the form of notification, gave me information much faster than the person who was trying to do kind of like a refresh, this kind of like a click and refresh. So yeah, and another metaphor that we can also use for this, the request response world versus event-driven, is a restaurant. Because if you want to order food, you need to call the person who will be serving you food, bring you a menu, and after that you have a menu, you have your payload of your request, you're sending this request, and the person will bring you food. In contrast, when you will be floating around a place where they have like food trucks, you can make a decision on your own based on the certain things that's going on. You heard there's like a shorter queue, you just run there, or they have like a better smell, and it was like, okay, so let's see what they have there. So restaurant is your request response paradigm. The food trucks, it is your event-driven system. My name is Victor Gamov. I work as a principal developer advocate at a company called Confluent. Anyone heard about Confluent before? Right, a few people. Good, nice. It's great that people get to know us. The company was started by original creators of Apache Kafka, and we doing a lot of things with Kafka, obviously, but also with different stream processing tools. Anyone here use Kafka streams for their stream processing? Very good, very good. Now we also are doing a lot of work with Apache Flink. So some of my work involved talking to developers who either use this thing or want to use this thing. Okay, and it's going to be most important slide. If you want to have slides, some resources, demo, you don't have to do photos. You can do photos to post it on social, like hashtag, I don't know, awesome talk from Kotlincon. But I will be posting video after that. All code will be there, slides, everything will be there. So feel free to take a picture of this slide. If you want to tweet about this, don't forget to mention me. My Twitter handle, conveniently Twitter. I still call it Twitter. This is how we're showing your age. Conveniently placed on every slide. So if you want to tag me, you can find it there. Now, I start with metaphor. Now you probably will remember those. Maybe you will not remember. But essentially, when we develop in microservices and using framework library, I don't know if I would get banned from this conference. I will call the Ktor framework. It's not a framework, right? It's not like a Spring Boot. Spring Boot is a framework. Ktor is more like a set of libraries, set of tools, like a toolbox, toolkit, right? So to building apps. And it doesn't enforce you any opinion whatsoever. There are certain sets of API that are very natural for you as a developer in Kotlin, and you use this to build your web services, building your microservices. And regardless what kind of framework we use, we're going to be focusing on Ktor today, but regardless what you use, it's just nothing changes. It is request response. Even if you try to do some real-time stuff like WebSockets or server-sent event, it's still, you need to initiate this initial kind of request because your HTTP request will be upgraded to WebSocket, or you need to subscribe to this, the server-sent event. So, but in general, it is always request response. In contrast with event-driven systems, and things happened in the form of events, and the different actors in this system, like I'm not saying actors in the world of kind of like Akka, just collaborators in this world of this event-driven system, they would choose to react or they choose not to react on this thing. The event-driven system that has Kafka in foundation, it also not enforcing you with any sort of mediation or any sort of kind of like orchestration. You will be choosing whatever you want to do with those events. So there's no logic built in. From one point of view, it is a good thing because again, there's not much of the opinion, so you can build whatever you want. From another point of view, sometimes people wanted to have something, and I had many conversations in the customers and the people in the community about, okay, so how I can build things, like in RabbitMQ, you have ability to define different topology, how the messages will be flowing through the system. In Kafka, you cannot do this. And that was by design, because Kafka was, messaging was kind of sort of like afterthought, if you think about this. Kafka was designed to be like very weird type of database, because storage and durability of the messages was in the first place, because this log of events, of messages, is durable. It is immutable. Every message in this log, if you send this to Kafka, it will stay there. And Kafka actually gives ability to model real world much better than any type of existing solution. Definitely not a relational database. In my opinion, and I can fight for this opinion, the most cumbersome, in most unnatural way, how you will be describing business process, or how you're describing a real life that happens, is using entity in relations. It's terrible. Object-oriented thing, and you need to like move from the object-oriented to entity relations when you need to do persistence and all this type of stuff. It's terrible. And if you try to model real life situation events, like things that you have order came into the system, you need to send this order through a set of pipelines. It needs to be checked if it was paid, and after that it will send to fulfillment. This order will be fulfilled. So it's not, if you ever design and wrote this type of system, you know what I'm talking about. You either breaking the rules of this relational database, you denormalize your objects in order to make things convenient to you, or you following toward normal form, you do denormalized entities, and after that you do joins and all this type of stuff. With Kafka, you can easily, or event-driven system, that matter, it can be Kafka, it can be Pulsar, it can be Kinesis, whatever you have. With this, you have ability to model if things happened. You will be able to model this as a set of events. So that's why event is just occurrence of something, and it can be a form of notification that doesn't have any consequences. Just you need to send notification, or it can be something that notifies you about the changing of the state. The example with order: every event that happens to this order will notify you about something changed with this particular order. And on the other side, somewhere who will be consuming this event, someone who will be listening this, they need to decide what to do with this data and how to recover the state. Maybe in some, like a back office system, you have a table that shows all the steps that this order went through in order to debug. But for your customer, you're only showing latest and greatest thing. Your order was processed, your order was paid, your orders was fulfilled, and order was shipped. And you don't have to present this information to the kind of like a full information. You don't have to present to your customer. So that's example of what we call stream to table duality. How stream that will be representing kind of like a set of events that happened to particular in a particular world would be mapped into state. You will notice that I love metaphors because the easiest way to remember it, easiest way to understand. Any one of you playing chess or checkers for that matter? It doesn't matter because when you're looking at the board, in this particular case, you see a set of figures, and one particular moment, if you just look on this one, you don't know how they end up there. You make assumptions because if you're playing chess, you know how things are moving. But when you're looking at the board, you see in a state. That's how you see on your database, generally. If you want to go and see a state of your order, you go and select star from orders where order ID equals 55 or 42. Now, but what's going to happen if someone will knock this board off? Oh. I'm checking if you are falling asleep after lunch, you had the coffee, so you need to be kind of like aware where I need to start adding energy to this talk. So the terrible thing happened. You lost your state. You don't know what happened. But if before you start the game, you'll have a piece of paper where you will start in the order of how you start moving figures, will get all this move written in any given moment of time, regardless if the state was destroyed. You will be able to replay all the steps and recover state. That's the beauty of Apache Kafka. Apache Kafka is your log that has immutable messages that you can replay anytime and recover state. Kafka can be consumed by multiple consumers, and in this case, this information will not disappear when they will be consumed, like you have in messaging system. Doesn't make any sense. So this is stream to table duality. You have your history, your ledger, your number of credit card transactions that you see. Like you see all this credit card transaction happen. And you turn this into table that will represent state. Your current balance, that's your state. Or your figures on the board. Now, can you turn a table into stream? Anyone done that in the past? There's a concept called CDC, or change data capture, essentially that allows to things what you do with your state. That's what we do. That's why I'm saying it's unnatural for people to do something with the state. Like in real life, if you say something, for example, you have a conversation with a significant other, and you say something that you're not supposed to say, as we usually men do, right? You cannot change that. It's gone. It's already, sent, and they receive it. So only thing what you can do, you can kind of like make amends and saying, hey, maybe I was wrong. And the same thing easily can be modeled with the systems like Kafka. So state of the person of the other side would be depend how well they will be processed this. And it's not how you would model this type of real life situation in database. But in the database we have this concept of change data capture, because even database not doing any writes into state directly, because inside database we have a write ahead log, special type of file that also has immutable records, and every time when the database crashes, what is happening? We're restoring the state of this database from this log. So, and we also can listen changes that happened with this data in the database through this change data capture. We can capture all the changes that happen: updated record, deleted record, inserted record. So we take in table, we turn it to stream. So stream to table, table to stream. It's a fundamental concept. I apologize if I did too much of the introduction if you knew this, but this is also very important because in the concept of the stream processing is actually we start doing something with the stream. And usually stream processing, this is something that we use to do. Nice, it's a good photo, send me. So stream processing, that's the thing what we do to get stream and turn it to table. Stream processing is a process, a tool set, a set of practices that allows you to deal with events as they arrive. Usually wear a different t-shirt that says Kafka and Flink, making future one event at a time. One event at a time, we're doing something. We're not doing this in bulk. It's not batching. In the streaming, we're dealing with one individual event. And as they move, meaning that we don't have to wait until everything will be done. We don't have to wait until all the data will arrive. There's the two concepts where the people need to understand the fundamentals in terms of what you can do with stream processing. And there's a stateless and stateful. Stateless is easy. Every time you need to do any type of filtering, maybe transformation, maybe a little bit changing format, you're updating timestamps, you turn them into local time and things like that. And you don't need to remember anything. With the stateless, it's absolutely no need to use any special tools. You can do things with Kafka and the simple tools like Kafka console consumer, and after that, send this data into, I don't know, like whatever your favorite console tool to parse the data and send it back. But with the stateless or stateful, where we actually need to know or remember things from the past, and we need to do something like this, that's very important. Another metaphor for you. You come into a coffee shop every day for the last couple years, and they cannot remember what you're ordering because you're ordering the same thing all the time, and then cannot remember your name, or they cannot remember like what you're ordering, so you need to start over. So there's no memory. On the other hand, if this the barista would be more client-oriented, they might have a list of customers and what the customers usually, or regulars, what they usually do. So essentially, the stateful stream processing, this is the barista because it knows past, it knows previous orders. Maybe you will also have in this ledger somewhere in this notebook, you might be having some loyalty points and all these kind of things. So the frameworks like Kafka Streams and Flink, for that matter, they do stateful stream processing. They manage state, and we're going to talk about this at the end, a little bit how it's done. But you need to remember it's state is something that you can kind of like get access because it's important for you. Count of messages, aggregations, all sorts of things that you can literally print as a report. This is something that you will caring about. So what is Apache Flink? Apache Flink, it's a framework. I can say that's a framework because it has a different sets of API, and it's very opinionated because different API will lead or will teach you to do certain things in certain ways. Also, it is a distributed computation platform. You're running clusters, you're running job managers, task managers, you're deploying things into this. But also you can do stateful, stateless operation, but more importantly, you can do bounded and unbounded operation. If you done anything with Kafka streams, it's always Kafka in and Kafka out. And the Kafka stream is designed to dealing with unbound messages. There's no end. You can do things like windowing. You can do grouping on certain windows. Usually it's a time bound because in general you don't care about infinity. You care about last 5 minutes or last 10 minutes or something like that. So Flink in the Flink APIs allows you to treat any type of stream, including stream that comes from Kafka or something that comes maybe from CDC logs and things like that. You can treat this not only how like unbounded stream, but also you can treat this as bounded. So Flink provides API that allows you to perform not only stream processing, but also you can do batch with Flink. In a methodology of Flink, batch is just one of the corner cases of stream. multiple use cases. We're gonna focusing on event-driven applications today, and I will show you like few examples. But it is a system that can be used in the data pipelines because Flink has high-level language for defining these computational jobs using language called SQL. You can perform all sorts of aggregation of batch and stream data. You can even kind of like join those things. You can get data from batches, and after that you can get data from streams. And we're going to talk about event-driven applications. Everyone loves diagrams, and obligatory slide that includes like all these things that Flink can do. General architecture, if you will be deploying Flink in your organization, in your business, is you start with some called job manager. This is something that will be listening request for you to submit your job. You submit your job in the form of a jar, and you know we GM folks love our jars, don't we? And the you can even do jars. Not even kind of like you can do this with Python as well. It sounds cumbersome. People on Python world excited about that they can do their Python thing in Flink only to the point when they start seeing the stack trace, because they are absolutely different from things what they saw in exception stack traces in the Python. So job manager will be receiving these like jars, and after that it will be responsible for sending this information to task managers. So task managers is going to be like a working horses of this process. You will be deploying them, and you can scale them separately. Inside the task manager, you will be able to define set of what we call it task slots. This is something that will be executing actual code, actual piece of your topology that you define in your program. Another cool thing about Flink is that it is not dependent on Kafka. If you're not using Kafka, you still can use Flink. Kafka is just happen to be one of the, I don't know, maybe 85% of use cases how people use Flink with Kafka, God bless you. But you can also do this with something else. And I'll show you example how I can get the data from Kafka, but also I can send the data to traditional systems that are designed to be, you know, kind of like a user-facing, like Postgres database. So, and you can have a custom sync, so you can write this data into whatever enterprise system you have. You can dump this into Salesforce or whatever. So you're running this in cluster. It has some benefits. It has a lot of headaches, especially how you're going to be, you know, debugging this, how you're going to be developing this, and all these kind of things. But in general, you're building a cluster of Flink jobs, and after that, you're submitting those jobs, and they're running in the cluster, and you hopefully will be happy with how they run. Yeah, we talk about this. So inside every Flink application is the simple concept. Many of you probably heard about this if you use this with any other data processing framework like Spark or Kafka Streams. Concept of direct acyclic graph. Anyone heard about this? It's nothing to do with graph theory. It's just a way how to describe whatever they try to do. Is the thing that has a start, it has an end, and something is going on in between. There's no loops, so you cannot go back. It's always one way, and so that's why it's like a cyclic. And that's where your message travels. So it's not like you kind of like applying this computation. You get the message one message from your input. Usually it's called source, and each individual operator will be performing certain type of task. Each operator can be perform any stateless operation or stateful operation. There's a different semantics available for you as a developer. You can do multiple things with this data. Some of the things that you need to know how to work in order to make the educated wish. Any Deadpool and Wolverine fans? Come on, people! wake up. It's important. That's going to be important slides. And there's lots of colors, so pay attention. We can run these jobs on multiple nodes, on the multiple task slots, meaning that you can have a parallel consumption if your source allows this. For example, Kafka allows to parallel consumption by increasing number of consumers that will be consuming from a particular topic. If you're consuming this data from somewhere else, you need to make sure that you know how to read this data in parallel. Next thing is that each individual won't get this from the source. We're passing to the next operator within this pipeline. We have a situation sometimes that we have a data that needs to be somehow collocated, but initially this data was not available in collocated format. It can be a situation that you didn't know upfront what's going to be your condition on how you will be joining, how you can perform this collocation, or maybe data came from the different sources when it ended up in Kafka in the first place. So operation that's called repartitioning, meaning that based on certain criteria, those individual messages will be gathered together on one particular node. In one of the most common cases, when you need to do this type of kind of like a stream to table join, stream to stream join, you need to find the ways how you collocate them on the same node, because you don't want to do distributed join. And this also involves some of the network calls. Flink is the heavily distributed system. There's a lot of things going on there in terms of network connectivity. If you need to move things from one place to another, we Java people love our serialization, right? Do we? It's incredible. It's the best thing we have in the JVM. No. That's why we have like so many different options for serialization, right? So if it would be so good out of the box, like why would need to, I don't know, use something else? And the Flink relies on certain predefined frameworks. It has a default or kind of like a fallback serializer that based on the Creo. Anyone heard this? It's the one of the serialization formats. Relies heavily on reflection, so that's why if it runs in your cluster, you need to go and enable a bunch of. It doesn't work well in Java modules, so it's fun, it's cool. You can see all this the weird messages and you don't understand what the hell is going on. So paying attention to serialization format is important in the world of Flink. It's not only important for your data. For your data, it's definitely important for you. But as a developer of these topologies, you need to also pay attention on how this data would be serialized between nodes, because they will be constantly moving. And like opposite process, we need to get the data from our topology to some sort of source. So we need to perform this collect operation, if you will, right? So we need to bring data from one place to another again. And the reason why I'm showing this to you is I like to call it is it's a part of mechanical sympathy. Anyone heard about mechanical sympathy? Few people. So essentially, it came from the racing world, and the idea was that the actual driver could make better decisions when they drive in the car if they know a little bit about how the car drives internally, how engine works, how transmission works, how all the things work. So that's why you, as an engineer, probably will benefit knowing how the things going on in terms of internally how things go on, so you can make the better decisions how to use these tools. Flink has SQL, but it doesn't make Flink a database. It's kind of weird, personally for me, for the person who started the career in the software development as a developer in object-oriented language. Technically, the Pascal was the first language, but after that it was C# and after that Java. I was enjoying being in the object-oriented world, and I really was certain that I don't have to learn SQL. We have Hibernate. Like, why I need to learn? And you're laughing now. because you've been here for a while, right? You've been in this industry for a while. And the freaking SQL is still kind of goes strong since 1992, right? SQL 92, the standard. They use it for database, for data retrieval, to run the queries. And now we have a SQL as a DSL to describe computational work. It's weird, it's cumbersome, and that's why people always get confused and saying, hey, this Flink thingy is a database because it has a SQL. And that's just a way how you can describe your topology. It's just, I'm not going to go very deep in this detail. I'll rather focus on something else because there's not enough time to cover everything. So 3 types of APIs. Data Stream API, people who use Java util stream or any type of low-level stuff will enjoy using this. There is a table API, there's a SQL I mentioned, and there's a table API. A table API is kind of interesting. Anyone using Juke, G-O-O-Q? Okay, all right, so you're gonna enjoy this as well. It's a table API that allows you to build your SQL queries using Java. I'll show you a few bits of this code. Allows you to write this in Java, and you can benefit from using high-level language in order to build your SQL. So it's not like you have your SQL in multi-line string. We have a multi-line strings now. But you have a strongly typed DSL that allows you to build your queries. You can have like a high-level. Anyone build the kind of query builder in their lives at least once? I know you did. Like we all did in this. Like, why we not use a SQL in the string? No, let's build a query builder. So it's a query builder for Flink, and actually it's not bad. It's quite all right. The API nice, and it's not terrible to use. Its level abstraction goes up and flexibility goes down. That's your regular game, right? We're expecting this. Flink SQL is targeted mostly to what we called data streaming engineers or data engineers in the past. And if you go in lower in API, you have developers there. You start getting people who understand the code. They actually enjoy writing this. So that's the thing. Now, it's state management. It is important. Oh yeah, we have a few more slides, and after that, we're going to go into demo. Now, some of the operations I mentioned, they require state. Some of them don't require state. So for example, here we're just doing simple filtering with our workloads. But if you perform some sort of aggregation, we can need to collect information. We need to store this somewhere. So in this case, this particular, this particular operator, in this case count operator, will have its own state. So in case of failures, so you don't need to replay. In case if you throw your board with your chess, you actually have snapshot of this board of the chess, so you can go in and recover. It's kind of like you take a picture before, and it's called snapshot. So there's 2 types of snapshots available in Flink. One is a save point, is something that you can initiate as operator in case you want to kind of like shut down your cluster, do some maintenance, and after that recover. And there's also checkpoints that will be automatically performed during the run of your topology. So Flink can do that. It has a few combinations. It has a local state, and it has now, since Flink 2.0, there's a concept of disaggregate. No. So essentially, like store can be fully separated from compute, and say your store can be on the S3. And that's going to be normal, and you kind of like separate your compute from your storage. Enough of this. You probably already want to see some demos here. Now, let me run this a little quick. What we have here. So first of all, I need to make sure that I have my components. And these components will include Kafka, it will include Flink jobs, a little bit of Kafka UI, and it will include Postgres as well. Next thing is that we might want to have, I want to have, is my API server. So the API server, where is it? Run API. Yep, fat fingers. So the in this case, I'm running Ktor is my API server, and in this case, Ktor will be listening Kafka topics and will be exposing certain APIs. So I have two use cases. Like I started with the flights, so I will have a real-time information on flights. I don't have real-time information on the flight, but I have a ChatGPT that can give me algorithm to generate very similar data sets that would be running in my particular demo. So when I can do make run simulation, it will start generating some random flights with some level of randomness. And also it will be generating some of the level of delay. So in this case, it will be just numbers going into Kafka. And in I need to bring this, if it works. Hopefully it will work. Come on, bring it in, bring it in. Come on, bring it in, bring it in. All right, so it doesn't. I tried. So let me show you what I have in my topic. I have a flight events in my topics. Let me do it this a little bit bigger. Messages, and all these messages that come, that would look something like this. So in this case, it is events that happened, flight number, the flight has some coordinates, so flights are moving. So I can take this information and already start doing something with this. So in this case, API server provides a WebSocket where our front end can connect and do something interesting with this. So for that, I need to now do front end. Hopefully it will. Come on, bring it in, bring it in. Yes, we can wait. We have all day on waiting those things. Come on. So what is happening? What is happening with this computer? Okay, thank you, thank you. We're going into the front end. Make sure that we have npm install. Everything is here. It's perfect. It's good. So we can run npm. I should have done the Kotlin to JS, right? It's a Kotlincon. I was supposed to be doing that. That would be much cooler. I just realized that, like, how silly me. Oh, anyway. So let's go npm start. Oh, start. And now I do have this type of window. And the messages that flying into this window, they will be served from the WebSocket and from the Ktor that will listen to Kafka topic and send this into my front end. So like all these events about the late flights will appear here. And this is kind of like let me see, where are we? Can it find? Yeah, local information. And this is like different flights around flying somewhere here. So that's the use case where we have these events going through the Ktor into, let me show you how this would look like. API server, the running Ktor, and we have routes. One route would be just a regular, the two REST endpoints. And in this case, call, or the way how the API would look like, it will be like this. We have a service that will be going and calling database. How we can get this data in database? If I would go here and show you database, hopefully there is no like delay flights. It's empty database. How I can get this data? I have information on flights, so I can run stream processing job that will give me a state, and this state would be queryable from this. So when I run this delay job, we're gonna see code of this job in just a second. but I just want to go ahead and show. It takes a few seconds to run. Yes, all jobs submitted, so jobs are running in my local Flink cluster, and now I have some information about delayed in what. So that's the state that I can extract from stream of these events that happened with the flights. And when I go and refresh, I will give me a new fresh information. So in this case, will give me different location. So this information already gives me ability to not only get something about particular flight, but also learn a little bit story. So I can do some sort of aggregation. That's where we go into the world of analytics. This is where we're trying to learn something, some story from the data. And now I can expose this information in the form of this delayed flight view. So this view would be typical something that you probably build this yourself multiple times. So that's why. Where's my routing? That's that's my services. That's my database service. Now, WebSocket service will be connected to flight event service that will be listening Kafka events, and after that, every event would be sent to WebSocket communication. Another job that I have is kind of like allows me to understand like how dense is a particular region with the flights, because I don't know if you follow the news on American news specifically, there's a place in US in New Jersey called Newark, and the last couple weeks it was under some scrutiny because there was old equipment that works, and there was some fire that bring the system down for 90 seconds, and that's not entirely clear to me. People who were like FAA people who worked there, they were traumatized and just quit the job. I guess there's a different type of mentality here. Anyway, but to the point. But what they were doing, they were looking into the radar, and they know like how dense certain the area of the air, and this information it's required for them to know because they will be able to navigate those flights. So this denseness, you see, this kind of like a thing on the card, we will be able to compute based on the information that we get about. On those flights. And if I go to my database, I have this flight density table. And when I go to edit data, and it gives me essentially grid on the map, you can have a grid certain size that will allow you to get those flights that are not on the map and somehow group them into kind of like into clusters. So, and we know how many flights are there together in this grid. Now, two things that I have here is my processor, and if I go here, my job, say this one, and see, I was telling you all good things about this stable API thingy, and after that, I'm doing exactly what I just said. I'm just putting everything inside my multi-line string. So that's kind of like one of the ways how I can define this job. So everything in Flink that comes as a source of data, it is a table. And the special table that allows me to, this is a real table because we're going to be using this as a sync, we'll write down. But Kafka topic also is a table. So now we have two tables, and we can operate on this table. So in this particular case, I'm using this the insert into sync, and also I perform small computation. So essentially, it's not stateful processing, because here I'm not storing any information. I'm just checking if it's a delayed flight or not. If it's delayed, I send this to sync. It's a different story if I will try to do aggregation. And it would look something like, damn it, I don't have it, the version of the table API I should have. And here I can perform this like a density query that will be turned into topology that will be run on top of this data, and so far and so on. And at the end of the day, we're gonna get this nice light demo. You can find this in my GitHub. I was having a blast wipe coding this demo. I learned a lot about the wipe coding thing, so you can grab this. Again, you don't have to take the picture if you want. You can take a picture and play around today and ask me questions. I will be here available throughout the day. And one more time, Flink is the system that allows you to integrate not only with streaming data, with batching data. It works great with any JVM technology. I prefer to do JVM, even though like Python people are, going crazy about this, how they can run the Python in the cluster like this. I didn't talk about time at all, but Flink has very strong and very the important capabilities with dealing with time and late events and things that happened on the stream. So it's just a great thing to have. And it's a stateful stream processing system. You have a control over your state. With this, my name is Viktor Gamov. Have a nice day. And we will be available for enhanced interrogation. Any questions that you will be interested to ask, I will answer. Not from the stage, though. I think we're running out of time because my timer says so. Thank you so much.